Hi students, so welcome you all again. We were solving the problems of exercise 10.1 yesterday, and we also covered some of the important topics, that is various forms of equation of line, that is point slope form, 2-point form, slope intercept form, and in this today's class we have to go for normal form of the line. Okay, so good morning everyone and welcome to the class. So tell all your friends to join the class so that we can continue. Okay, so already I have started the class. You can tell all your friends to join the class. Clear? So today we have to go with the normal form of the line. Clear? So let us see normal form of the line. Clear? Here normal form means, see what is the meaning of normal form. You can observe that the perpendicular distance from the origin is given. See this. The perpendicular distance from the origin is given for this particular line L. So this is called the normal form of the line. That means the perpendicular distance which is given to the line from the origin is called normal or the normal form of line. Clear? So that means here totally you have two lines. Here totally you have two lines. One is the perpendicular line drawn from the origin. You just see there is a perpendicular line drawn from the origin to the line L. You can see that here you have perpendicular line. See this? This is the perpendicular line drawn from the origin to the given line L. To the line L. Okay. So this perpendicularity is called normal to the line. That means the perpendicular line from the origin to the line L is called normal. Clear? That means here normal is P. That means the distance of the origin from the line L is P. So I think all of you have understood what is the normal, okay, or normal form of the line. So now using this diagram, now we can write our explanation of the diagram. That is, let L be the line, let L be the line, let L be the line, and P is the perpendicular distance. P is the perpendicular distance for the line from the origin, okay. So now you see the diagram. From the diagram we can write some important terms, that is this point A. Now I will take this point A as x comma y, okay, and here it is perpendicular, okay. So from the triangle AOM, now we have to solve for x and y. Clear? So now let us use the angle omega. See, this is all your rough work. See, this is your rough work that you have to understand very clearly. So now you can see here, that is using triangle AOM, I will define sine theta. So what is, sine omega, because here you have omega, I will define sine omega. So therefore sine omega is what? Opposite by hypotenuse. So you see the angle omega, and you tell me for this omega, this is the opposite side. Clear? So if you want to know this opposite side, you have to check on y-axis. So that will be opposite length is y. You can see from here. So opposite length is y and hypotenuse, you know that this is p. Hypotenuse is p. Okay. So from this you can get sine omega equal to, see here, sine omega equal to y by p, and perpendicular distance is p. So therefore p into sine omega equal to y. Here perpendicular distance is unit length. Unit length, that means 1 unit. So therefore y will be equal to p sine omega. So if it is unit length, then you can take it as 1, no problem. But here you just take that y equal to p sine omega. On the same way we can define cos omega. So that is adjacent by hypotenuse. Here adjacent side is x, that you can see here. So therefore x by p, therefore x will be equal to p cos omega. X will be equal to p cos omega. Are you getting my point? So therefore this is all your rough work. From this I can write directly from the diagram. I can write x is p cos omega, y is p sine omega. From the diagram, this is point on line L. Point on line L. So quickly all of you tell me, have you understood this or not? So quickly all of you tell me, have you understood this or not? So because I has to remove this rough work, so this rough work is very, very important. If you know this rough work, you can understand this point. So now this point is on line L, that is x comma y. So here x comma y is on line L. X means p cos omega and y means p sine omega. On line L, that is you can take x comma y is nothing but p cos omega, y is p sine omega. Okay. So now I will remove the rough work. Because I need to solve the theorem here. So that's why I need space. So I will take out this rough work. But you note down this rough work also in your notes. At the side of or the corner of the page, you have to write it. Whenever you are preparing for annual exams, you will not get confused. Clear? Okay. So now you got the point x comma y. Now you got the point x comma y on the line. Clear? Now here you see line L is perpendicular to the line drawn from origin. Okay, or you can take it as normal, no problem. So now we know that L1 is perpendicular to L2 implies L1 dot L2 equal to -1. If the two lines are perpendicular, the product of those two lines is equal to, M1 into M2 equal to -1. M1 into M2 equal to -1. That is, if two lines are perpendicular, then the product of their slopes is equal to -1. That is M1 dot M2 equal to -1. Clear? That is, if two lines are perpendicular, it implies M1 dot M2 equal to -1. So now we know that line L is, you can take line slope of M1 is line L1 and M2 is line L2. So you see here, for M2 what I can write. you can see this line. Let us take this as L2 and let us take this as L1, no problem. So now L1 gives you M1, L2 gives you M2. What about M2? You see here angle with the x-axis is omega. So now using this omega you can write M2 of slope L2. So if you using this L2, if you write M2 using angle omega, this will be tan omega. So quickly tell me all of you, have you understood this? The slope M2, because line L2 is making angle omega with the x-axis. Line L2 is making angle omega with the x-axis. Using this angle I can write tan omega, that is M2. That means slope 2. Clear? So now using slope 2 I can write slope 1 because I need slope 1. Okay. So now I got M2 is tan omega. Now I got M2 is tan omega. From that I can write M1. See how I can write M1. M1 into tan omega is M2. That is equal to minus 1. Now M1 is equal to minus 1 by tan omega. M1 is equal to minus 1 by tan omega. Okay. So some of you are not telling you have not understood. You can watch this video again to understand it, no problem. But here you have two lines. Please remember, I will explain once again because it is important. You have this is line 1 and you can see that this is line 2. Both are perpendicular to each other. So we know that if L1 is perpendicular to L2, M1 into M2 equal to minus 1. This all we know. So now for L2 angle is omega. So using this omega you can define slope of L2, that will be M2 equal to tan omega. Okay. So now write M2 here, that is tan omega. So from that M1 will be minus 1 by tan omega. Okay. So some of you have not attended the class. Tell all of them to attend the class. Clear? So now M1 equal to minus 1 by tan omega. Now we have to write the equation of line 1. Okay. So why I am solving all these things? Because we have to write the equation of line 1. So now on this equation of line 1, we got one point P cos omega and P sin omega. This is your x1, y1. Now you got slope, that is M1 equal to minus 1 by tan omega. For this line 1, now you got, see, now we have x1, y1 as P cos omega and P sin omega, slope as and M as minus 1 by tan omega. Okay. So now using x1, y1 and slope, you can solve the equation of line L1. You can use x1, y1 and you can use slope. By slope intercept form, you can write the equation of line L1. That is important for us. So therefore, equation of normal form will be, equation of normal form implies right slope intercept form, that is M equal to y minus y1 divided by x minus x1. That you can write. Otherwise you can also write with the equation of y minus y1 equal to, you can take it as M into x minus x1. Okay. So when slope and point is given, point slope form, you see point slope form. Okay. So I am using point slope form, the equation of point slope form that we have previously solved in the previous class. You can go through the point slope form. The equation of point slope form is y minus y1 equal to m into x minus x1. Okay. So by using point slope form, that is y minus y1 equal to m into x minus x1, you can write in the place of m minus 1 by tan omega. In the place of y1 you can write p sin omega. In the place of x1 you write p cos omega, and you can simplify it. So that we can do here. So for that I will take one more page and I can solve it. Okay. So let us take one more page for this, and we can draw this, no problem. So what is our equation? Our equation is y minus y1 m into x minus x1. So you can see your y1 is p sin omega. Y1 is p sin omega, and slope you can see minus 1 by tan omega. X minus x1 you can see this is p cos omega. P cos omega. So therefore y minus p sin omega, this is minus of cos omega divided by sin omega, x minus p cos omega, because here you can write tan as 1 by tan theta as cot theta. So cot theta you can replace it as cos omega by sin omega. Okay. So you just see minus 1 by tan omega is cot omega. Cot omega you can write cos omega by sin omega. Now you simplify it. Y into sin omega minus p into sin is sin square omega, minus into this term minus x into cos omega, minus into minus is plus p cos square omega. Okay. So exchange the terms, take x cos omega on this side, it will be plus x cos omega plus y sin omega. Therefore this is p sin square omega plus p cos square omega. So therefore x cos omega plus y sin omega equal to p times of sin square omega plus cos square omega. That will be x cos omega plus y sin omega equal to p, because sin square plus cos square is 1. So therefore this is your required answer. So please remember, this is going to be very, very important. Okay. So that's why I am telling, please understand this. Please understand this. Clear? So I will explain it again. Please understand so that you can solve it on your own. Clear? Here what they are asking, equation of normal form. Here they are asking equation of normal form. So what is the equation of normal form means? You first understand it. They are asking equation of normal form means the equation of this line L1. They are asking the equation of this line L1, which we have taken here. Clear? So to take the line L1 equation, we need one point and one slope. Are you getting my point? So to derive the equation of that line L, I am doing all this drama. Okay. So for this line L, first I will find x and y using this point A. What we have done, see, using point A. This point A, first we have solved x comma y. First we have solved x comma y for this point A, which is on line L. So for that, if you take x comma y, this will be p cos omega, p sin omega. P cos omega, p sin omega. Once you get the point, then you use L1 is perpendicular to L2. That means m1 into m2 equal to minus 1. So from that you can write slope of m1, because For L2 you have angle omega. Using this omega you can write tan omega, which is slope of L2. So using that tan omega you can get slope of m1. Once you get slope of m1, by using this equation, in the place of x1 you write p sin omega, in the place of y1 we write p cos omega, in the place of m we write minus 1 by tan omega. Okay, so from that you can understand, by replacing all those terms, here minus 1 by tan omega is cot omega, that is minus cos omega by sin omega. Multiply this term to LHS, y sin omega minus p sin square omega, minus x into cos omega, minus into minus is plus p cos square omega. Therefore exchange the terms and you simplify it, you will get x cos omega plus y sin omega equal to p. So quickly all of you please tell me, have you understood this? If you have not understood, please watch this video again and again. You can watch this video and you can try to understand. Still, if you have any confusions, you can give me one message, I will reply to that. Okay, so now we can go for the next problem. So that is, find the equation of, see this problem. Now I will solve this problem, you can see this. That is, find the equation of line whose perpendicular distance from the origin is 4 units and the angle which the normal makes with the positive direction of x-axis is 15 degree. Okay, so here first you understand the problem, what they have given in the problem. They have given there is a line L which is at a distance from the origin of 4 units and it is making 15 degree angle, and they are asking the equation of line L, okay. So say that you have to find the equation of line L which is at a distance of 4 units from the origin and which is making 15 degree as an angle, so with the x-axis. Now you have to find this equation of line L. Clear? So already we know that the equation of the normal form is, equation of normal form of line L is, you can write it as P, see here, P equal to x cos omega plus y sin omega. So here you can see that omega equal to, here you can see that omega equal to 15 degree. So using this omega equal to 15 degree, now you have to find two values, that is cos 15 degree. So please directly take it as formula, that is root 3 plus 1 divided by root 2. Okay. Next, sin 15 degree, that is root 3 minus 1 divided by 2 root 2. So y means you have to check cos of 45 degree minus 30 degree. So you simplify this, you are going to get this result. On the same way, sin of 45 degree minus 30 degree, you can solve this and you can get this. Okay, but here please don't write all this directly. You write cos omega is root 3 plus 1 divided by 2 root 2, sin 15 is root 3 minus 1 divided by 2 root 2. Directly you have to take these two, no need to solve this, but you have to remember cos 15 is root 3 plus 1 divided by 2 root 2 and sin 15 degrees root 3 minus 1 2 root 2. If you want the proof of this, you can simplify this in your rough work. put cos of a minus b formula, put sine of a minus b formula, you will get these results. Okay, but don't write this thing in for a problem. You have to write directly cos 15 and sine 15. Now p value is how much? 4. Okay, so 4 equal to x into cos omega is root 3 plus 1 divided by 2 root 2 plus y into root 3 minus 1 divided by 2 root 2. So here you can choose LCM as 2 root 2. So therefore 8 root 2 will be equal to x times of root 3 plus 1 plus y times of root 3 minus 1. So this is your answer. Clear? So this will be your answer. That is 8 root 2 equal to x times of root 3 plus 1 and y times of root 3 minus 1. So by explaining this much also, some of you are not attending the class. Okay, if you do like this, that is not going to be very good. Only 78 students are present today. It has to be nearly equal to 100. Okay, minimum it should be nearly equal to 100, but some of you are not attending the classes, so they will go through the consequences what they are doing. Okay, no problem. Now quickly all of you reply me, have you understood this problem? Quickly reply me all of you, have you understood this problem? Normal form of the line, very important. Please remember, normal form of the line, very important. And this problem is also very important. Again I am telling, because most of the times they have asked in the exam, and this is also important with that theorem. So please practice those things. Clear? Okay, now we can go for the next problem. That is exercise 10.2. Exercise 10.2. Clear? So here equation of the x-axis and y-axis. Equation of x-axis already I have explained once, that is equation of x-axis equal is, or you can write implies y equal to 0. Equation of x-axis means y equal to 0, because see here, this is x-axis and this is y-axis. Okay, so now it is common sense that if I want x-axis, this y must be always equal to 0. If y is always equal to 0, this line reduces and it will be fixed at origin. It will be fixed at origin. Okay, so generally we say y equal to 0 is the equation of x-axis, and the equation of y-axis is x equal to 0, because now I want to remove this x-axis. If I want to remove this x-axis, I make this x as 0, so it will remain always here. So and y-axis will remain as it is. Therefore, for x-axis, y equal to 0 is the equation. For y-axis, x equal to 0 is the equation. So please remember this. Okay. So I think 30 minutes is already over. No problem. We can continue with one more problem, because this was very easy. That is equation of x-axis is y equal to 0, and equation of x-axis is y equal to 0, and equation of y-axis is x equal to 0. So please remember this, equation of x-axis and equation of y-axis. Now let us go for the second problem. That is passing through the point and slope is 1 by 2. Again this is point slope form. This is point slope form. So what is point slope form? point slope form is y minus y1 equal to m into x minus x1. Okay, so here y1 you can take 3, so therefore y1 is 3 and slope is 1 by 2, x1 is minus 4. So from this 2 into y, 2y minus 6 equal to x minus into minus is plus 4. Therefore x minus 2y plus 4 plus 6 equal to 0. X minus 2y plus 10 equal to 0. This is your required answer. Okay. So x minus 2y plus 10 equal to 0 will be required answer. Clear? So from this you can understand, no problem. So now we got the problem of line passing through the point minus 4 comma 3 with the slope 1 by 2. So quickly tell me, all of you, have you understood this? X minus 2y plus 10 equal to 0. Very good. Now let us go for the next problem. That is again passing through the point 0 comma 0 with the slope m. Again the same equation, point slope form y minus y1 equal to m into x minus x1. So here y1 is 0, m is m, x1 is also 0. So you can write it as y equal to mx. Y equal to mx. Clear? This will be the answer for your next problem. That is y equal to mx. Clear? Now I will go for passing through the point 2 comma 2 root 3. Passing through the point 2 comma 2 root 3 and inclined with the axis angle of 75 degree. Angle of 75 degree. Okay. So we shall continue with this problem in the next class. Clear? Because it takes little bit more time. So that will be very late for you all. It will be more than 40 minutes if I go on solving like that. But no problem. Quickly tell me, all of you, have you understood normal form of the line? Normal form of the line, problem on the normal form of the line, and these problems are very simple. These are small children problems. Okay. Exercise 10.2, problem 1, 2 and 3. These are the small children problems. So I am not worried about those things, that you can understand. But here the important is normal form of the line and the problem on normal form of the line. So if you have understood this, very good. So quickly, who all not subscribed the channel, please subscribe it, and also you can click the bell icon for the notification. Okay. So thank you everyone. We shall meet in the tomorrow's session and we can continue the problems. Clear? Okay. Thank you. Be safe and bye.